Hello everyone, my name is Paweł Zielonka and I am a PhD student from Wrocław University of Science and Technology. And today I would like to present you some information about the image evolution in pultruded composite bulbs using acoustic emission system. My supervisor is Professor Grzegorz Lesiuk. In the beginning, I will start about description of the pultrusion process, what is it and which type of the materials we can manufacture. Then I will go to the specimen characterization and next will be the experiment which we conduct. And at the end, I will show you the results and of the discussion. All of the works were the part of a project, a new generation of hybrid composite rods for concrete and soil reinforcements, which is financed by Polish government. Okay, so pultrusion process is a manufacturing process, manufacturing continuous process of composite profiles. In the beginning, we have the fibers. In the shape of the wing bobbins. The fibers is going through the guide table to the resin bath, which could be warmed, and in this resin bath the fiber is impregnated. The wet fiber is going through the A guide and is pre-shaped in the cross section of the profile. In heated dye, our fibers are cured, and in the end we have the solid profile. The continuous movement of the systems is provided by the pulling system, and in the end we have the sew machine which cut our profile in the specific dimension. We conduct our experiment in the smooth composite bars made from the GFRP material. The dimension of the bar is 10 mm of the diameter, and in the right you can see the manufacturing system in our laboratory. There is a resin bath where we warm our resin, heated dye with a circular cross section, the main pedal control where operator could put the parameters of the process, and the pulling system. Our first experiment is a double cantilever beam test with acoustic emission system. We put the acoustic emission sensor in the end of the bar. There is a crack cut by the wire saw machine, and after cutting the crack, the pre-crack was made for the 5 mm of the dimension. And here is a picture from one of our tests. And here's the results from the DCB test. In the DCB test, we try to localize our crack tip. Here is the events which we measure using acoustic emission systems. The threshold was held in the 75 decibels, and as you can see, most of the events was measured in the behind of the tip, which is probably the cracks or fiber broken. And in this graph, you can see the cumulative number of the events during the time, and this curve is a force. So you can see that when the force is rising, and the lamination is starting. The cumulative number of the events is have a higher increment, and after that we have the linear curve when we have the lamination. Next experiment is a 4-point bending test, and in this experiment we try to correlate the amplitude, the frequency of the events in our to detect the broke of the specimen. Here are acoustic emission sensors, and this is experimental setup in our laboratory. And the results from the tests, as you can see, just before broken, the cumulative number of the events is rise significantly, and this is much better see in this picture. In the beginning we have mostly linear curve, then the nature of the curve is changing, and after after maximum force we are changing the nature again. So it could be the linear, but we don't check. Okay. And conclusions of our research: we can use the acoustic emission system to check the distraction mechanism in our composite material, to conduct the frequency, the amplitude, or the duration of the events due to the failure in our composite. So after the evaluation of the results, we can say that the resin, or we must change the resin on impregnation of our fibers. Acoustic emission can provide us, can give us the location of the failure. It is really important when we try to find the lamination in our composite, or in, for example, in the pressure vessels, when we try to detect the leakage, for example. And the acoustic emission systems can be used in SEH systems to implement the safety of our component and unload them just before the broken. And this is everything. Thank you for your attention. Yes, please.
Thank you for a really nice talk. I was wondering which type of acoustic emission sensors were you using? Were they rope band? Or resonance?
Which type of acoustic emission system?
Which type of acoustic emission sensors?
It was a piezoelectric.
Yeah, all of them, obviously.
Yeah,
I mean,
but with the wide range of the frequency.
Have you inspected maybe then the frequency dependency, like power spectrum density or so? Or you have taken only the amplitude of your events?
We measure the frequency, but the resin or the fibers have different frequency of the measurement. So we just have take these sensors to measure all of the events that we can. And after that, we have the evaluation of our results. Yeah.
So you mean you didn't check yet the frequency?
I don't have this graph in this presentation, but for this DCB test, we have the different frequency of the matrix, and then we have the gap and the frequency of the fibers.
Yeah, okay, it would be interesting too.
I could later show you the...
Yeah, and why have you used two sensors? Were you trying to make the location
Yes.
Ah.
Here is the location. Maybe I don't talk about this.
Maybe.
The black line is our empirical measurements that we use by eye, and this is the acoustic emission events. And all of the events which we measured was in this area. This is the crack tip of our that we can see, and the measurement was in this area. It's 20 millimeters after the behind the crack tip.
Okay. Okay. Thank you. Maybe I will ask again something else.
There's a question back there.
I had the same question about the sensors.
Okay.
But I mean, you're talking about frequency. Are you acquiring waveforms and then determine if an FFT and the frequency from that? Is that correct?
Our acoustic emission systems give us the whole number of the frequency, the results, and after that we
Let me rephrase the question.
Use
Which
the Python
acoustic
we can
emission
use.
system were you using? Which manufacturer or equipment manufacturer?
It was a valley.
Oh,
Valley.
thank you.
Okay, thank you.